Some circuits contain resistors arranged in a triangle called a delta or pi configuration. Others have resistors meeting at a central point called a Y or T configuration. When a circuit has a delta or Y that can't be simplified using series or parallel rules, we can convert one into the other, delta to Y or Y to delta. After the conversion, the circuit usually simplifies into simple series and parallel combinations. Let's learn the conversion formulas and see two examples. Here are the formulas. In the delta configuration, we have three resistors: RA between nodes B and C, RB between nodes A and C, and RC between nodes A and B. In the Y configuration, R1 connects from node A to the center, R2 from node B to the center, and R3 from node C to the center. To convert from delta to Y, R1 equals RB times RC divided by RA plus RB plus RC. R2 equals RA times RC divided by RA plus RB plus RC. R3 equals RA times RB divided by RA plus RB plus RC. The mnemonic. Each Y resistor equals the product of its two neighboring delta resistors divided by the sum of all three delta resistors. For the reverse, Y to delta, RA equals R1 R2 plus R2 R3 plus R1 R3, all divided by R1. RB uses the same numerator, divided by R2. RC uses the same numerator, divided by R3. The numerator is always the sum of all pairwise products. Example 1. Delta to Y. We have a 40-volt source on the left. At the top, a 5-ohm resistor connects to a bridge network. The bridge has a delta formed by three resistors. RA equals 25 ohms at the bottom, RB equals 100 ohms on the upper left, and RC equals 125 ohms on the upper right. Below the delta, we have 40 ohms on the lower left and 37.5 ohms on the lower right. This bridge can't be simplified directly with series parallel rules, so we'll convert the delta to a Y. The sum of all delta resistors is RA plus RB plus RC, which is 25 plus 100 plus 125, giving us 250 ohms. Now apply the formulas. R1 equals RB times RC over 250. That's 100 times 25 over 250, which equals 10 ohms. R2 equals RA times RC over 250. That's 25 times 125 over 250, which equals 12.5 ohms. R3 equals RA times RB over 250. That's 100 times 125 over 250, which equals 50 ohms. Now the circuit simplifies beautifully. On the left branch, R1 of 10 ohms is in series with 40 ohms, giving 50 ohms. On the right branch, R2 of 12.5 ohms is in series with 37.5 ohms, also giving 50 ohms. These two 50-ohm branches are in parallel. 50 parallel 50 equals 25 ohms. Add R3 of 50 ohms in series. 25 plus 50 equals 75 ohms. Finally, add the 5-ohm resistor. 5 plus 75 equals 80 ohms total. The current is 40 volts over 80 ohms, which equals 0.5 amperes. The power from the source is I times V, 0.5 times 40, which equals 20 watts. Example 2. Y to delta. This time we have a 2 ampere current source on the left with voltage V across it. In the middle, a Y network with R1 equals 20 ohms going left, R2 equals 10 ohms going right, and R3 equals 5 ohms going down. There's also a 28 ohm resistor across the top and 105 ohms on the right side. We need to find V. The Y network prevents simple series parallel reduction, so we'll convert it to delta. For Y to delta, first calculate the numerator. R1R2 plus R2R3 plus R1R3 equals 20 times 10 plus 10 times 5 plus 20 times 5. That's 200 plus 50 plus 100, which equals 350. Now divide by each Y resistor. RA equals 350 over R1. That's 350 over 20, giving 17.5 ohms. RB equals 350 over R2. That's 350 over 10, giving 35 ohms. RC equals 350 over R3. That's 350 over 5, giving 70 ohms. Now we simplify. RC of 70 ohms is in parallel with the 28 ohm resistor. 70 times 28 over 70 plus 28 equals 1960 over 98, which is 20 ohms. RA of 17.5 ohms is in parallel with 105 ohms. 17.5 times 105 over 17.5 plus 105 equals 1837.5 over 122.5, which is 15 ohms. These 20 and 15 ohm resistors are in series. 20 plus 15 equals 35 ohms. This 35 ohm combination is in parallel with RB of 35 ohms. 35 parallel 35 equals 17.5 ohms. Finally, V equals I times R equivalent, which is 2 times 17.5, giving us 35 volts. Let's recap. Delta to Y conversion. Each Y resistor equals the product of its two neighboring delta resistors divided by the sum of all three. Y to delta. Each delta resistor equals the sum of all pairwise products divided by the opposite Y resistor. Use delta to Y when the delta blocks series parallel simplification. Use Y to delta when the Y is the bottleneck. In the next lesson, we'll explore mesh analysis.